Good morning. Today we're going to talk about titrating a strong acid with a strong base. And what I'm going to do is take 50 milliliters of 0.200 molar HNO3 and titrate that with 0.100 molar NaOH. We aren't going to be in lab to do this, but you've done this before with titrations in first year chemistry. When we did first year chemistry, the typical thing to do was to find we knew the molarity of the acid, the volume of the acid, we know the molarity of the base, and then we titrate to an endpoint, and we can actually predict what that volume would be. And in this case, we know three things, but we don't know the volume of the base. So we would guess that would be 0.100 liters or 100 milliliters. Let's see if that makes sense. 50 milliliters of 0.2 molar HNO3 is neutralized by equal moles of NaOH, which would be twice as many milliliters of something of half the concentration. So that seems to be logical. When we did titrations, we probably neutralized to an endpoint, and then we used that to find an unknown molarity. So we knew volume of acid, molarity of acid, volume of base, and then we worked to find the molarity of the base. But here we're just predicting where our equivalence point is, and if we take acid and base, strong acid and strong base, the equivalence point will give a pH of 7. But what about the points all along the way as you do the titration? Could you figure out the pH? And yes, this is corresponding to titrations in 15.4 in your book. They do a lot with millimoles. We'll try to keep it a little bit simpler. This is also very much like we did in chapter 14 when we did an excess moles of acid or excess moles of base problem. So here we go. The initial pH, because it's a strong acid, it's 0.200 molar. I just take the inverse log of that, and I get 0.699. Let's say I add 10 milliliters of base. What's going to happen is, okay, we're not near the equivalence point, but I just figure out moles of OH minus. I figure out moles of H plus. I end up, those will cancel out 1 per 1. So what happens is I subtract the difference. I get 0.0090 moles excess H plus, and I divide that by the total liters in the system, which was the 50 from the original acid and then the 10 of the base I added. And that, notice that didn't change the pH much, it's still 0.82. Okay, now I do it with 20 milliliters, and again, I figure out the difference in moles, divide it by the total liters, I get to 0.94. When I get halfway there, notice I still have twice as many moles of acid as base. Okay, I take that, divide that by the total liters. I'm still at a very low pH, 1.30. Okay, let's look at what happens if I get to the equivalence point. It's 100 milliliters of the NaOH. Okay, is going to give me as many moles as the 50 milliliters of this stronger concentrated acid. So essentially I have nothing in excess, and that pH is 7.00. What if I keep adding base? Now I'm going to have excess base, and this pH is going to skyrocket and keep going up. I could do 150 milliliters of the NaOH. I figure out moles of OH minus. I figure out moles of H plus, and I subtract to get 0.0050 moles of excess OH minus. Divide that by the total liters, the 150 of the base I added, and the 50 of the acid I added before, and I get a pH of 12.4. I could keep going with 200 milliliters of the base added, and I get even a bigger difference. I get 0.0100 moles of excess over 0.250 liters, and now the pH is up to 12.60, but the pH is already so high, so it can't really get much higher. What does the titration curve look like? Let me unclip here and try to show that piece. And here is a titration curve. Let me try to line that up, okay, for this. I think you can see it pretty good, and this is also in your packet. So notice I have the really, really low pH. When I get close to 100, it skyrockets. And even though this is a very steep line, in reality, it should even be steeper. Within a milliliter or two, you're going to go from a pH of 4 to 10 really, really quickly with the way the logarithmic scale works. The equivalence point will be right at 7, and then we get excess base, but it tails off because there's just, with this much solution, it just won't get any higher with that molarity of NaOH that we add. So what would titrating a strong base, starting with a strong base and titrating it with a strong acid, it would look very, very much the same, except you'd start in here very high pH. It would gradually dip very slightly, significantly plummet, and then it would tail out over here. Okay, I'm not showing an example of that, but it would essentially be the same type of thing, except you'd start here with the high pH. You'd see a very, very steep drop, and then you'd see the leveling off at the low pH there. Stay tuned for weak acid titrations and weak base titrations.